The CSAP management platform provides extensive support for managing container-based deployments. This support is provided by the Docker and Kubernetes plugins. Alternately, the Podman and CRIO plugins may be utilized. While this screencast will focus specifically on the support for container deployments using Docker, much of the content applies to the Podman and Kubernetes plugins as well. CSAP container support key features include support for ad hoc interaction, typically done early in the development cycle, inspection and troubleshooting workflows, including either the UI or the Docker CLI, definition and deployment of Docker services, including orchestration workflows, such as waiting for container 1 to complete startup and then proceeding to container 2. CSAP provides an extensible platform via the CSAP API interface. This simple shell API enables the deployment, start, stop, and configuration that can be used to customize service platforms. In this case, the CSAP Docker package enables both the configurability and the deployment of the Docker daemon. The Docker service is typically included in the base OS cluster. The base OS cluster is typically used to include all of the deployment artifacts required on all hosts in the application. Note that packages may be associated with a running process, as in the case of Docker, or for Java, it is simply the JDK on the file system. Selecting the Docker service reveals all of the instances currently deployed. The table view provides the host name along with the most recently collected resource consumption data. The Docker service definition includes a template file used for generating the core Docker configuration file. The daemon.json file includes settings for image repositories, logs, and more. The Docker service in this particular application also includes a CSAP service.yaml file. CSAP service.yaml files are useful when overriding a template definition versus creating an entire copy of the entire service template. The logs view for Docker defaults to access the systemd logs. The host can be selected to quickly navigate across all instances. The CSAP deploy logs for Docker can also be viewed. Note that the deployments include verification tests, and here they were successful. The instances view allows one or more instances to be selected for performing operations. Let's look at the available performance data. Every CSAP service instance automatically has OS resources collected and recorded. The CSAP Docker template also includes the specification of key performance indicators. Let's navigate back to the cluster view and then switch to the Performance tab, which is the default when logging into the application portal. The Performance tab on the application portal includes the host container view. This is a set of graphs highlighting key performance indicators. The views default to aggregate performance indicators across all instances in the environment. The host view can also be selected to view items per host. Here we're selecting the running containers and then launching into the analytics portal. In this instance, we can view the average number of containers running over the past 24 hours and then optionally compare it to some other time period. This may be useful when comparing pre-migration to post-migration of software releases. Returning to the application portal, the Host tab provides access to real-time views across several domains. The Container view highlights Docker and Kubernetes resource summaries. Note that while Docker is deployed on all hosts, only 3 of the hosts include Kubernetes. The host views also include links to the analytics portal. By default, the values shown are the 24-hour average. Sorting by instance count, Docker is shown with 7 instances. Comparing to a few days earlier, note that the total storage used has increased substantially. Selecting the service name reveals only the instances where the deviation was greater than 20%. While a separate session covers the CSAP editor in depth, a quick tour reveals dockerd is included in the base OS cluster. Only the host assignment is defined for the current environment. The service assignment is done in the default environment that's shared across all of the environments. Exploring that, we can see the explicit assignment. Now, let's look at a service that uses the Docker runtime. Note that test Docker Nginx is assigned to multiple clusters. There are 3 instances in the Kubernetes provider cluster. There are 1 instance in the Docker verification cluster. In the selected environment, note that the Kubernetes provider cluster definition is doing both the service assignment and the host assignment. This will override any service assignment done in the base environment. The key attribute that determines the runtime environment in a CSAP service definition is the service profile. In this case, note that the assigned service profile is Docker. Service definition modifications may be performed either on the form-based tabs or on the specification tab directly. The only other required attribute for management is the Docker image name. The other attributes enhance manageability. By default, CSAP will build the necessary API parameters when deploying and removing the service. This may optionally be specified in the definition using the Docker CLI format, as shown here for the NFS service. This may include any of the CSAP service template variables and includes support for running privileged containers. Having seen how to add a Docker service to the CSAP application, let's go ahead and perform a deployment of the newly added service. Deployment of container-based services follows a typical workflow. Select all instances, select deploy. Note that the auto start button has been clicked. The container image will be installed on all of the selected hosts and then started. Note the deployment and start logs are automatically shown as the deployment proceeds. Finally, selecting refresh on the logs will detect the log file and show the container logs as well. Note that both resource consumption and application performance metrics are available. Let's look a little closer to see how metrics are configured for this service. The typical starting point for collecting performance data is reviewing the documentation to determine how to enable and collect performance data. To enable metrics on Nginx, the nginx.conf file was added to the service definition. Editing the file, we can see the configuration. The key element for Nginx is the addition of the status directive. Note that the service definition files are stored in a Git-backed folder that is subject to being reloaded. In order to be made available as a Docker volume, a CSAP job has been added to copy the service definition files to the service working folder. We can review the service configuration by launching the service template editor. Selecting the container tab and then selecting the volume subtab. Note the inclusion of the container mounts, including the nginx.conf file. The Jobs tab shows the pre-start event, which copies any definition files to the working folder. And finally, note the Performance tab reveals the performance collection configuration. In addition to looking at the logs, to verify the deployment of a service, the instances views can be used to launch either a single or multiple services. Note, any service launch can be added to the landing page using the environment editor. One convenient feature of the container support is the ability to access configuration and data files inside the running container. To modify the Nginx landing page, the file manager on the agent portal is launched. By default, the view is restricted to the configured shortcuts. Opening up the application folder reveals the Nginx folder. We can do a quick change and then reload the landing page to see the modified changes. When launched from the service instance screen, the agent portal is useful when wanting to dive deeper into the runtime environment for a specific service. Logs may be viewed along with resource consumption for the process. Application performance indicators that we previously defined are helpful. The host OS information is always critical as it provides the complete context for the environment. While the default view in the file manager is filtered to only include the service shortcuts, the full host file system can be viewed. This includes access to all of the running containers deployed on the host and their respective file systems. Here are some demo volumes that could be used to persist changes. They were included in the service definition. The container shortcut mounts the root of the file system. We can navigate as needed to view the same content of the application shortcut shown above. The OS Explorer view may be used to view all of the containers deployed on the host. Note, the Docker container defaults to use the same as the CSAP service name. Selecting the process tree command will show us the OS process information. The OS Explorer view can provide complete access to the container configuration, launching a browser at the defined ports, viewing logs, or running a command inside the container. Here is an example of a simple ls command. In addition to the command runner view, the OS Explorer CLI may be used to run commands and quickly view the output. There are several sample Docker commands included. Shown here, for example, is docker ps. The command output can be modified and executed. The OS Explorer includes the ability to perform ad hoc container operations outside the scope of a CSAP application definition. This is useful when wanting to explore new capabilities. This includes pulling images to the host, creating and configuring containers, and then inspecting the log output.